All right, here's part two. Sorry it's taking so long to upload these. I'm working from my hotspot, my phone, and it's just taking way longer than normal. So thanks for your patience on that. But we are going to start part two on rational inequalities. We have 8 steps again, but they're a little bit different. Um, Tomorrow we'll look at more difficult rational inequality problems, but we'll start off pretty easy in today's lesson. So let's take a look at our rational inequality, okay? So in step one, it says relate to zero. That's already done here, okay? So step one is done. Step two says find the LCD and multiply by the missing factors and write over one denominator. That's step 2 and 3. Notice that this is already written over one denominator. So we do not have to do step 2 and step 3. Those are already done for us. So if you don't get an example like that, then you'd have to condense, follow that process to get down to one fraction, one denominator. All right. So step 4 is kind of all along those same lines. Don't need to do any of that when you already have one fraction over here. Step 5, that's where we are. Step 5 says you have to set the numerator and the denominator equal to 0. Okay, so 1 equals 0 doesn't make sense, right? 1 equaling 0, that doesn't make sense. Let's go to our denominator and set our denominator equal to 0. So we have x equals -4. Okay, what do you guys think about that? Remember, we're working in the denominator. So can x equal a -4? No, that indicates to us that we have to have an open circle on -4. Okay, have to have an open circle. All right, so this is still our critical value, similar to the last examples that we were working with. The numerator, if we did have a numerator, I'm reading step 6 over here on my other slide, that can be either open or closed. All right. But when you're working with a critical value in the denominator, it will always be an open circle because what you're doing is you're setting the denominator equal to 0 and finding that critical value, which is an undefined value. So always an open circle for denominator critical values. You might want to highlight that in your steps. So we have only 2 regions here. We have this region and this region, okay, because we only have one critical value. So we are going to pick -10 and 10. Just pick a point in each region. And we're going to use the inequality to determine whether or not the region should be shaded or not. Okay, so over here, we're looking for a value that we could plug in for x that would produce a number greater than or equal to 0. That means we're looking for positives. All right, so if I put a -10 over here, a -10 plus 4, that's going to be a negative. So we have a positive value divided by a negative value. That is going to be negative. Let's try over here. Plug in 10. We'd have 1 over 14, which is positive, or we do a positive divided by a positive, which is positive. And so this is the region that we shade. Okay. This is our solution set. We can write our solution set, step 8, as in set builder or interval. That's up to you. So here we have x such that x is greater than -4. In interval notation, it's -4 to infinity. Simple, right? Simple way to start us off with rational inequalities. All right, let's go to the next one. All right, when we take a look at this next one, notice that we still only have a single fraction over on the left side. It's already related to 0, so we don't have to do steps 1 through, is it 1 through 5? 1 through 5, I'm sorry, guys. 1 through 4. 1 through 4. Steps 1 through 4 are done. Let me write that down so you guys know. Steps 1 through 4 are done. Okay. Step 5 now, when you're working with rational inequalities, you set your numerator equal to 0 and your denominator equal to 0. So that's the difference. Numerator equal to 0, denominator equal to 0. And we find our critical values that way. Our numerator actually produces a critical value this time at x equals -6, and our denominator produces a critical value at 1. Okay, once we have those critical values, this is step 5 and 6. We're going to put those critical values on a number line. Here we have our number line. We have -6 here and 1 here. So now we do have 3 regions to test, okay? We are looking for, go back up to the original. We are looking for values that are going to be negative. Not values that are going to be negative, but values that make this negative, right? Because we're looking for less than 0, so that's negative. Looking for that. All right, so let's pick some points in our regions. We have -10 here, we have 0 here, and a +10 here. All right, we have our x plus 6 over x minus 1. When we replace that with a -10, we get a negative on top and a negative on the bottom. When you divide two negatives, you get a positive. So positive there. Here we have a positive and a negative, so that's a negative. Here we have a positive, and that's a positive. So we are looking at the negative region, so here. And let's talk about those circles. Right? The numerator can be open or closed, depending on the sign in the original inequality, and that is an open circle at -6, and the denominator always open circle. Okay. All right, last step, step 8. Let me write this in both ways, and you guys can pick which way you like. 4. Okay. Let's go on to another one. Why don't you guys at this point pause, practice, and then hit play. This is our last one. And like I said, tomorrow we'll, see how those steps 2, 3, and 4 play a role. But for now, just making it a little bit easier. So step 1 is already done. Step 2, 3, and 4 don't have to do. We only have one equation or one fraction over here. So let's move on. We have to find our critical values. We set our numerator equal to 0, our denominator equal to 0. We have x is equal to 1/2. So 1/2 is a critical value. And -3/5 is a critical value. Okay. What are we looking for though? When we put our number line together, put in a -3/5 and a +1/2. Okay, go back up here to the sign. We're looking for values that will make this greater than 0, so we're looking for positives. Okay, let me go ahead and write my over there. Okay, let's talk about our circles. Denominator, always an open circle. So let's put an open circle there. Numerator can be open or closed. The symbol tells us that this one is going to be closed or included. Okay, let's pick values. Let's pick a -10. Let's pick a 0 and a +10. All right, let's plug those in. We get a negative here divided by, what do we have there? A negative. So negative times negative is positive. All right, let's go over here. 0, that's a negative. That's a positive. A 0, a negative divided by a positive is negative. Keep going. Positive, positive, positive. All right, we're looking for the positive region, so we shade there and there. Last step, write our solution. X such that x is less than negative 3/5, or x is greater than or equal to 1/2. Set builder is there. Interval will look like this. Negative infinity to negative 3/5. Union, square bracket, 1/2 to infinity. Okay, and that's it. All right, let me know if you have any questions.